This is a video of a talk from Crater Remote Conf given to a live audience in February 2016. This video was made possible by sponsors like Modulus.io, okgrow.com, and SpaceDojo.com. If you would like to find out more information about upcoming conferences, be sure to go to conf.crater.io and put your email in the form that pops up in the lower left corner. Enjoy the video. Welcome back to Crater Conf. We'll call this like day 4, I guess. Thanks for tuning back in for the makeup sessions. So the first session we're going to do today is going to be Sam Hatoum. So Sam was working on Velocity, and that's now transitioned over to Chimp. And I think he also runs Zolvio, which is a consultancy that helps you. I don't know. What do you help people do, Sam?
So we help companies deliver higher quality features faster. We do so by consulting, and we also have a bunch of products, which you mentioned. Chimp is one of that allows them to do that.
Yeah, nice. All right, I'll let you take over from here.
Okay, great. Hello, everyone. So I'm going to talk to you about delivering higher quality features and how you can, first of all, make them higher quality, and then how you go faster. Before we dive into the how to go faster technique, which seems to be what most people are interested in, I just want to talk a little bit about what quality actually means. And so, how does software get produced? You start off with this idea, and somebody will take this idea and get it all the way to production, where you will hopefully have happy users. Now, the process to go from an idea to a happy user involves two main activities: some business activities, and then we get some technical activities. Now, the user is going to see the sum of everything that's coming through this line. So that means if I have an idea over here, I have to develop this idea. So I might go and create perhaps some wireframes. I might go and just write a document that I would go and test that idea with. I might send an email to somebody. They might respond back. And so what happens is it goes through this design process over here, which is pretty messy. And it kind of goes back and forth and back and forth. And eventually we end up with something that comes out of the business activities that looks like what you want to actually create. So over here you have the ask, like you know what you're asking for. When you have that ask, you then take that to the development and you create a specification. Now you may not do a formal specification, but you might send it by email, you might write it on the back of a napkin, you might have a conversation, you might have a whiteboard session. You may have a use case, you may have a given when then scenario, you might have a user story. There's a bunch of different forms of specifications, but there's always a specification, and it's always based on some ask. And that ask is always a result of some idea and some other activities that create that ask. So this is kind of the life cycle of an idea becoming code. So the point that you have this spec, even if it's just communication, a conversation, the development person, the developer, they'll take this and they'll generate some code. And that code will get deployed maybe to a QA environment or a staging environment. And then after that, somebody looks at it, says, yes, this is good to go, and it gets deployed to production. So where is the quality in all this? The quality is everywhere. The quality is in how much research did you do? The quality is in how much research did you do at this point to make sure that the idea is a good one? Did you do some of the lean practices like customer development? Did you do customer research? Did you test your wireframes with people? These are all quality functions that you'd be applying at this stage. When you get further down the line, when you're asking for something, how much effort did you put into the specification? How well did you specify it? Did you just say to somebody, can you please build me a login screen? Or did you give them specifications that say, when the user enters this, then I should see that. When the user enters this, then if they enter a bad email address, it should give them a message. So that's the quality of the specifications, or the quality of the ask that's coming through. Well, as a developer, what quality practices do you apply there? Do you say, I'm going to write some tests, so do some test-driven development? Maybe you're doing some acceptance test-driven development. Maybe you're not doing any testing at all. You might have things like linting. Those are considered quality functions. Anything that you apply at the development level that helps you create better code is going to be a quality function, and especially things that are validating that what you're being asked for is being delivered is a quality function. Quality assurance in and by itself is a quality function. You're applying quality to see that the code that was created here actually passes. And even all the way when it gets to production, are you checking that the production instance or the application that's on production, are you checking that that's valid? Are you seeing that all the services are up, that the page is up? So you can see quality applies across the entire line. So here's an insight that I've had. In order to go faster, you need to have more quality functions in your process. The more quality functions that you can put into your process that you automate, especially with the automation, of course, then the faster you'll be able to deliver. So the lesson there is you look after quality functions and the speed looks after itself. Let's start here with the ask. I won't go beyond this point. So beyond this point is all the product market fit stuff you might do, the lean practices you might do. At Solvio, we actually have that capability. One of my co-founders, he deals with this whole section, which is how do you make sure that you're building the right product? So little comment there. Yes, exactly like that. That's exactly what it is. So yeah, at this point, there's how, what is it we want? Now, from this point onwards, it is how do we make sure that we've got a valid ask? How do we make sure that gets delivered through here? So the first point is to understand what asks are all about. So we said this is the business and that's the tech. In the business, we have a business domain. If we're talking about, for example, a car manufacturer, we would look at their business domain as they obviously have models. Although that looks like a boat, it's actually a car. So they would have cars. They would have a dealer. They would have, a service shop. They would have, what else would they have? Maybe they might have some advanced connected car sort of capability where they can talk to your car. So all of these things are within the business domain. So let's just call that the business domain. And if we look at the business domain purely without any computer system, without any IT whatsoever, we would look at this as a bunch of interactions. So we would say you have a customer. A customer would go to a dealer in order to purchase a specific model. I could operate this business on a piece of paper. I don't need a computer to do that for me. In fact, maybe when Ford was around in 1912 or whenever they came up with their cars, they probably didn't have a system. So they did this all on paper. They probably wouldn't have had connected car either. But when the customer wants to go to get their car serviced, then they would go to the service shop, and maybe they would, do things like book an appointment. Book an appointment. So that's the business domain. And when we ask for something from the tech guys, we're typically asking them for something that is within the business domain. So understanding the business domain first, properly, is an activity that the business guys can do that's very important before going into development. And a lot of times this is actually completely missing. It's in people's heads, but nobody really knows exactly what it is that they're doing. They don't put a name around it saying, we're doing business domain functions. Just like in the spec, nobody says we're writing a specification, even though they're asking for things to be created. So they're specifying what needs to be created. So to have a higher quality spec, your spec needs to be referencing your business domain. You need to start creating a language that says, this is a customer, which is different to the agent that is a dealer. Maybe the agent is a dealer, this guy's a customer. So you start to create this domain language about the business. And that domain language, you use it when you're asking. And so again, this is something we do instinctively, but maybe not so disciplined. If you focus on a domain and you have a conversation over the domain, and you have that conversation before you go into development, and you involve three people, three disciplines, someone from business, someone from tech, like the development, and someone from test. So they call this technique the Three Amigos. When you get these three disciplines, so it might be a product owner, a developer, and a tester, or if you're a smaller team, the tester might be the developer. Point is to get more eyes at this point on the spec before it even enters the system. That in itself is a quality function. You're applying a quality function that identifies defects before they even enter your system. So it turns out, crazy statistic, 50% of defects enter your development way before your development even starts, which means 50% of your defects actually are in the specifications themselves. And the less disciplined your specs are, the more likely you're going to have defects in them. So you get somebody from biz, you get somebody from tech, you get somebody from test, you put them together and you get them to talk about the business domain and what it is they're being asked for. And a good technique is called specification by example. And this is where tools like Cucumber come in, and we'll get to that in a second. But what you're really doing is you're going through examples of the business domain. So you're saying, all right, what is the ask? What do you want from this system? And let's say I am a person that bought a car. So as a customer, I want to book an appointment. That says I want to book an appointment so that I can service my car. So this, you may be familiar to, it's the Agile user story narrative. And it has three parts that help you structure the context that you're working within. It says who this is about. So as a customer, I want to book an appointment so that I can service my car. So this is the feature that I want. And over here, it's the benefit that I will get from having this feature. So that sets the narrative. And I would say, can you give me an example? And we say, all right, well, let's say I've got a car and I want to, I've just bought it and I want to go and get it serviced. So I'll book an appointment and, the mechanic will look at it and let me know what's wrong with it. And so somebody from the test discipline will say, what about people that are under warranty? Is that included? Like, what if somebody is not under the warranty? You might go, oh yeah, of course. So now the scenario changes from just a customer coming in to service their car, and it's a customer that is still under warranty. So you create scenarios, and the scenarios become things like customer within warranty period. And then you have another scenario that is basically the customer is not within the warranty period. And this spec that's forming here is called specification by example. So we're taking the business domain, we're getting 3 people that understand the business domain, we're going and creating examples of what might happen using this domain language. And then we're using a structure that says who this is for, what they want, why they want it, and a bunch of scenarios that tell us the different ways in which they can achieve this value. So then we have customer within warranty. Given a customer purchased a car at this so-and-so date, when they book an appointment, then they are informed that their appointment is free. Another scenario, customer is out of warranty. Given the customer purchased their car 3 years ago or 7 years ago, when they book a service appointment, they are notified that they will be charged $2,000. And so now you can see how you can go into very detailed given when then scenarios that are completely about the business domain. They have no reference to the user interface. They don't talk about how the value is achieved. They talk about what the value is. So a good specification does not tell you how it's doing it. It tells you what it's about. And then the how it's done is what happens over at this side. I actually have to charge my battery. Yeah. Excuse me. All right, so very quick summary. An idea forms, we want to take it to production. We have a specification that gets formed. When we know what we're asking for, we should go through the domain, and we should create a Three Amigos session to highlight specific slices within the domain that we want to represent as scenarios. We give it a story narrative, and even though this actually has no effect on any test automation whatsoever, it is extremely important in making sure that this set of scenarios, are coherent. They're all about the same business benefit. They're all about the same person. They're all about the same feature that's required. And they end up creating slight differences between the slice within the domain. So we now have a spec. It's in the form of given, when, then. I'm just going to take a quick shortcut and say that we've now created a nice specification. So now the tech team has got this spec, and it's the result of the tech team being involved in the first place, so they have full context of what it is they're developing. The business is happy, they've gone through the scenarios and things make sense. And the test team, they know exactly what to expect when it hits them. So the next thing the tech team should do is create a copy of this domain. Where that's the business domain, this now becomes the domain model. It's a model because it's a subset of the real world. And we're not going to say how tall the agent is and what color eyes the customer's got, but we need enough information here just to represent and even like replicate the business process and allow that business process to happen online, say. So this is what the domain model looks like relative to the business model. You have a class called customer. You have a class, or a domain entity actually is the right thing, called a service. You have a domain entity called, like the, I don't know, maybe connected car. You have a domain entity called model. You have a domain entity called dealer. And finally, you have agent. And so you can see there's a direct relation between the domain model and the business model. They're actually identical, and they should be identical. So now what we can do is employ a technique called modeling by example. That is, we take the example that we created here, the given, when, then, and we look at things inside, like given the customer purchased a car on so-and-so date. Well, customer, that's a domain entity, purchased a car on so-and-so date. That means that they own a car. So we'll have that model as part of the customer, or a link to the customer. There's an attribute of when that car was purchased. So we get a domain model that's being formed from the examples. And as we add new examples, let's say there's a new scenario that is about, given I've serviced my car, then the connected car should send a signal to the car saying the service complete, or maybe send it to the person's phone saying service complete. So if we've got this new blue scenario, then what we end up doing is modeling this new blue scenario here. And that's what modeling by example means. It means you take the specification by example and you use it to create your model. So what you can really call this section here, the modeling by example, it's like a simulation. What's really happening is you're getting the simulation that's going between the ask, it's going to developers. They go and test this this new idea over here in the domain, and then once they're happy with it, they will take it back to the business guys and say, hey, look, things have changed slightly. When we were coding, we discovered that we also need to add so-and-so attribute. And so the business might say, yes, that makes sense, or no, wait, you've done something here that's not quite right. So you get this circle, this interaction, very short feedback loop that happens between the business and the tech. And this is what's called domain discovery. So notice how much quality functions, how many quality functions we're putting just on the specification piece, because so many problems come from the specification being incorrect. What this is really doing is allowing us to fix those mistakes very quickly without having to build a UI on top and take care of persistence and take care of all the framework and infrastructure and everything else we have to do. This is just purely about the domain. So you go through this a few times, this iteration. You go from asking the specifications by example, group of people, you take it into the domain model, you start to test it with the domain model, make sure it works, make sure you've got the right entities, make sure you have the right attributes. As you do that, you're slightly modifying the spec and making it closer to what it should be. You go back to the business, you do this a few times, and then finally, what you end up with is this stage here. When you have very, very high confidence, I'm just going to use 90% because I can, to say you got really good 90% confidence that this spec is spot on. It's had everybody look at it. We've gone through a simulation, we've gone through examples, it matches the domain model, we're using the right language, we're using the right terminology, it fits in our domain. Like, you're pretty confident that this specification is good. So now, from here onwards, you go and you build your UI, you go and you build your database persistence layer and all that sort of stuff, which typically developers find this quite easy. Like building the UI, putting some views on top of an existing domain model is typically quite easy. So this is how you can massively reduce the number of defects you've got, and this is how you can have a really high quality domain. Now, as you write UI tests, and as you write the persistence layers, you wrap all of these with unit tests. So I won't dive into unit tests in this talk, but suffice to say that unit tests really protect you against, say, a specific UI component not doing what it should do. So let's say I've got this new book appointment screen, and it's mapping directly to my model. So when I say book an appointment for so-and-so time, it's supposed to behave in a way that when I put the wrong value in, when I put a date in the past, it says, hey, sorry, your date is in the past. I don't really need to take care of that at the domain level. That's a unit level thing. So then my unit tests will be very good at highlighting any issues I've got there. So where does Cucumber fit into all this? Well, Cucumber and the whole behavior-driven development philosophy is actually this whole practice end-to-end. People think BDD is just this one tiny, just like unit testing, but different language. It's actually not true. Unit testing lives over here. I've just highlighted that here. But BDD, or behavior-driven development, is actually this entire picture. It is about starting off by defining the behavior of your system in terms of raw concepts at a domain model level and specifying what the system should do, not how it does it. So whereas unit tests validate how something is being done typically, the behavior-driven development is more about defining what you want your system to do. So when we start off with something like this and start to create examples, and these examples look like given, when, then scenarios, what Cucumber allows us to do, or any specification by example tool, there are actually a couple of others, it allows us to take this spec and run domain simulations. So, you see that blue one right there, that's a domain simulation right there. Let's say I come up with another couple of scenarios that do this, then this would start looking this way. And I would have a simulation of the business case in the domain model, and that's what Cucumber is meant to do. That's what any specification by example tool is meant to do. It runs a simulation against your data model, your domain model, and it validates that the domain model is correct, that you're maintaining the integrity of the domain model. So let's say, for example, I come up here and I say, I've got something that that is incompatible with this other scenario. So here I've got a service should send notification to the user by mobile phone. And then somebody else comes along and they want a new scenario, and they say, we want it to only send notifications to by email for some other reason. And so the developer comes along and starts to do this, and they realize when they go through the simulation that there is a contradiction between the new scenario and the old scenario. And they can discover this before writing a single piece of UI or a single piece of database on top. Take this to the other way of writing software where people don't take care of these things. What will typically happen is you will only find this out after you've built out your entire system. And the cost of correcting a mistake like that is actually really quite high. So ultimately, by having practices like this, you also end up developing software for much cheaper. It takes more of an investment upfront to do this technique, but once you've got it down, then it makes things cheaper down the line. And Cucumber helps you run these simulations that all save you money. Okay, so that's generally how we go about reducing the cost of bugs way before they even enter the system. What I'm going to talk to you about now is how to create an architecture that allows you to follow this. Sorry, give me a minute. If you have any questions, do post them now. I'll come and answer.
Yeah, we'll save the Q&A for the end.
Oh, okay. All right. I wish I had a button I can just click and this thing would go away. So we spoke about the domain model. Let's just call that the domain core. And so the domain core will put in what's called this hexagonal architecture. So you may have heard a lot about things like MVC. I think MVC is actually mostly a broken concept. It works up to a certain point, but after a certain point, it stops becoming maintainable. As your software gets super, super complex, it actually becomes harder to maintain. I'm going to give you an alternative, and then I'll say why it's harder, why it's easier to maintain this way. So this thing here is called hexagonal architecture. You put your domain core in the middle, and then what you have is the concept of ports. It's called hexagonal, but actually it's as many sides as you like. So off the domain core, we would have persistence. off the domain core, we might have a REST interface that allows people outside to talk to it. Off the domain core, we might have an application layer that then talks to a UI. So this looks very similar to MVC, and that's when MVC is actually pretty good. Just a UI talking to an application, talking to a domain core. It's nicely layered in that way. But what this really does is it allows you to do all things framework-based, like in Meteor specifically. You would have all things that are about collections and what have you. They would be all inside the application layer, or they may be inside the infrastructure layer. So with this hexagonal architecture, what it allows you to do is focus all your testing on the domain core. You do your domain discovery on here, so you have even another port for doing testing, and this is where you would use something like Cucumber. And that allows you to exercise just the domain, all your business logic is good. And then you have separate concerns for the infrastructure and for the application being done outside. So that's really the key to being able to test your application, is to have a very good separation of concerns principle throughout. By having a hexagonal architecture that looks like this, which is basically a domain as the core and everything comes off it as ports, it really allows you to centralize all your unit testing on the parts that matter and all your integration testing on the parts that matter. So when we look at Cucumber tests, because they're taking lots of components together like this, they're actually doing a form of integration testing, and they're verifying the integrity of your domain model, and therefore allowing you to change over time, add new business rules, and make sure that you're just focusing on the business rules. So that separates out the business rules from the rest of your app. Once you have that, then when you have a UI for it, that's typically going to look something like this, like a form, let's say, and you can have crazy amounts of unit testing around that form. React, for example, is doing an amazing job of giving testing tools for that. At the application layer, you might have it do things like to go to the infrastructure, pull out the user that's currently logged in, come back, use that user, get it like the user account, and then run some domain logic on that user account, and then give it back to the UI. By doing these sorts of things, you end up going, okay, the responsibility of the application app is just to take data, validate it, send it to the domain, bring it back, give it to the UI. That's all nice and isolated. I can unit test that. The persistence, maybe you're just doing some like standard Mongo stuff, just writing directly to the database. Maybe you're doing something like CQRS, where you're separating the reads from the writes. At least you're doing that all here as part of your infrastructure and your persistence. And again, you can unit test that, and you can run integration tests around that. So I like this diagram that the guy who invented modeling by example created, which is this. He says, if your application is like a tree, like that, and basically you've got all these different branches, they're like your features. And then on the branches, you have all these little leaves. Then the way that your unit tests and so forth should operate is that for each leaf, you would have a unit test. And so you'd have unit tests all around. And then for the domain part, you actually just have like the big roots, if you like. And so the really cool thing is that by following this separation of concerns and by using Cucumber to test your domain at an integration level, what you get for free is this. You get the testing triangle for free, because every single part here has unit tests. You end up with thousands of unit tests in your application. Every domain core unit has unit tests. Every infrastructure unit has unit tests. Every single thing in here has like unit tests. So that's at the unit part. And then for the service level, you start having hundreds of unit tests, because all the scenarios, or all these like main big groups, they're all being tested at the domain level, and you've got hundreds of them. You don't have as many as the unit test because you're testing different scenarios within the domain core. Maybe you have a few tests as well, integration tests that sort of test the infrastructure and the persistence together. So these would all count towards the hundreds. And then finally, the really cool thing is that when you have your given when then scenarios and you're using these to test your domain, you can actually repurpose the exact same specification, but instead of going directly to the domain, you can now get them to go through the UI to talk to the whole application. So for example, you'd say, given the customer bought this car on so-and-so date, you go straight to the database and you put the car in there. Whereas in the domain, you just created a car within the domain. When you're testing the entire app together, you can actually go and put something directly in the database. And then you say, when the user books an appointment, in the domain test, you do it at the domain core. But when you're running the full end-to-end, you say when the user books an appointment, and you go through the UI to do it. And then you say then they should receive a confirmation. And again, you would maybe instrument the email and find out if the notification was sent. So it's actually really cool that the exact same specifications that you use to do the modeling by example, you can reuse those by creating new step definitions to then go through the entire application. And in so doing, you end up with tens of those, because you can just choose a few critical path ones that you want to test. So whereas the domain, you might have 12 different scenarios for a given feature, when you're doing the end-to-end test, you just pick one of those scenarios and you say, this is a critical path. And so the critical path one ends up being part of the UI test. And automatically, by using this technique that I just showed you, you end up getting the perfect balance of the testing triangle. So the original title of the talk was, how do you deliver higher quality features faster? By going through the domain and figuring out your domain first, making it match the business model, by separating your concerns, by putting a high amount of domain level testing through your cucumber tests, by sticking unit tests everywhere and using an architecture that allows you to separate concerns, you'll end up with a very high quality solution, because everybody's looked at it, and you'll be able to go faster because you've stuck to the testing triangle, which puts thousands of tests here, hundreds here, and tens here, which means this will run, your test suite will run very, very quickly. And you've automated your entire test suite. So combine those two things together and you get high quality features faster. All right, I'll open it up to questions.
All right. My video is not popping up. I guess I'm not necessary. Let's see. So the first question is from Robert. How to avoid features creeping. So I think he's talking about like scope creep, maybe. Like once you settle on a spec, I'm thinking maybe is what Robert means. And he can confirm in the comments if I'm wrong.
Okay, so I'll answer that anyway. I think it's a good question. How do you stop scope creep? Well, what you do is, one thing I didn't talk to you about over here, I'm just going to remove this cucumber tests, is you have a hierarchy for your specifications. So any business will typically have capabilities. And within those capabilities, they'll have feature sets. And within those feature sets, they'll have features. And then underneath here, you have scenarios. So capabilities, feature sets, features, scenarios. Features and scenarios, these are the specs that you end up having in like a tool like Cucumber, and you have all these scenarios that you run through. Above here are the business capabilities. So for example, in the car manufacturer example, their capabilities would be servicing, sales, marketing, things like that. When you go to feature sets, their sales might be like used car sales or brand new cars or cars made to order. So there's 3 different feature sets of the sales. Now within there, you go to a specific feature and you say this feature, for example, is about users can search their local market, or maybe a user can search an international market for an exotic car. So these are like all features of the feature sets. And so the way that you control scope creep is, as a developer, or even just as anyone in the team, you say, what capability are we trying to build here? If you're trying to put too many capabilities into the one feature, like somebody says, I want something both from sales and marketing to be in this feature, then it becomes easier to split that out and say, this feature is about one scenario. So what you do is you ask the person that's giving you the feature to give you an example, and you want to make that example as simple as possible, represent it in scenarios, and any other features, any other scope creep items that come in, what you want to say is, okay, it looks like that belongs to a different feature, or it looks like that belongs to a different feature set, or maybe even an entirely different capability. Does that answer your question?
Yeah, I think so. He clarified saying something when the client is asking for features all the time during the dev process.
Oh, I see. Okay. So what you want to do is you want to get a lockdown. Once you're working on a specific scenario, you want to keep that small. And so if it's small enough, it means that you lock down your environment. Excuse me. You lock down your development so that you only ever take the next requirement once you finish the scenario that you're currently on. So yeah, it's a couple of things. It's making the scenarios as small as possible, and then as a discipline for the team, you have to say, I'm currently working on this feature. And so what you need to do is give them a backlog and say, here's scenario 1, here's scenario 2, here's scenario 3. This is what's currently in play. If you stop me doing this, this will be throwaway, and I can take another one. But if you give them this backlog that they operate within, and you make it single file, you say, I can only work on one thing at a time, and this is the order that you have to work with.
Creating a domain model and specs seems like a time-consuming process. How do they help me deliver features faster?
So the investment up front is definitely not as quick as going straight into development. Right? So when you first create the specs, it is definitely an overhead. But actually the investment saves you time in that it's reducing the amount of defects you have to fix further down the line. So you create really high quality specs. You go through this process of separating the concerns and so forth. When it comes out the other side and the QAs look at this, well, it goes to production. The number of defects that will come back as a result will be much lower. There is actually a study that shows that people that actually did domain modeling, they reduced their bug count that gets to QA from, by 50%. So let's say they used to get 100 bugs being pointed out by QA. They started using this process or the domain modeling piece, and that number halved, which is pretty awesome. The other thing is just doing standard unit testing. It's the same argument. If you do unit testing, it adds development time, but it saves you a lot of time going forward because it catches regression bugs and therefore reduces how much time you actually spend doing development.
Yeah, and that's kind of why I threw the question out there. That seems like a common argument against testing that I hear a lot. And frankly, like, it was a common argument I had when I first started developing. Like, it seems stupid to write all this testing code when I'm already writing code in the first place, and it seems like I'm doubling my efforts. But in the end, I think you're right. Like, having those tests there give you confidence later. And I think it's likely true as well with this, domain modeling probably gives you confidence as you move code from idea to production. So
it's exactly identical. And yeah, it really bites the problem at two parts. The typical defects are going to enter either before the development cycle or during the development cycle, where unit testing helps you with stuff that enters during the development cycle. This domain modeling upfront helps you with stuff that enters before the development cycle.
Yeah. And you know what's interesting too is like the one place where we're really committed to stuff like this that I worked at was Gaslight, and they even committed to pair programming, which I think there's been some studies around that it helps cut down on bugs as well. So
Yeah,
you
yeah.
could start approaching zero bugs in your code.
And the other thing that makes it quite difficult as well is that the business people that are the ones that are driving the decisions, they're the ones with the money. And typically what they want to see is just more features being delivered.
Mm-hmm.
So, if I take this opportunity to tell you about a little something we're working on, what you've really got is that over time, you have features being produced, and maybe that feature number is going up over time, right? And the business is really happy. But then the number of defects that's occurring is taking up this much time too. So if you've got testing, then it levels out this number because you catch them earlier. If you don't have testing, as this number goes up, your ability to deliver features will start to rapidly drop because there's only so much time that a developer can spend. Now, that economy is not very visible to business people because they only see today or today. It's a very gradual creep for them, so they don't tend to see the cost over time. Now, what if you could give the business a metric like this? What if you can give them a metric that says, here's how much you spent on bugs this week. Here's how much you spent on bugs this week. Here's how much you spent on bugs this week. When you start giving them this number, they start to go, oh, wait a minute, this is costing me a lot of money. So how do we fix that? Well, you invest in testing. So we're actually building a bunch of products that tell you exactly this information. Coming soon.
Nice. All right. So Robert, what is a good team size to deliver fast but organized stuff on a very low level?
I'm sorry, could you repeat that?
Yeah, hold on. Getting a little echo. What is a good team size to deliver fast but keep organized stuff on a very low level? And then also, should the business guys be a tech to be a part of the dev process?
Right. So they should be available for you at the domain discovery. So the two questions, I'll answer them backwards. Should the business guys be available at dev? Yes, because you will always have questions, especially if you're working in the middle in the domain piece. And at that point, they should be available to you because the sooner they can give you a decision, the sooner you can continue without being blocked or make assumptions.
But I think the question also said, should they be a tech, like a tech person or someone familiar with technology?
No, absolutely not. Like that's the purpose of the domain discovery, to have what's called the Three Amigos, or the three disciplines. You want to put all the disciplines required in this. So somebody from marketing, somebody from legal, if that's what it involves. If you're doing something, if you're developing a legal-based feature, then you want a domain expert to be present so that you can take the domain from their head and model it. So yeah, these guys should be involved at the domain discovery, but at the technical level, not necessarily, not unless they are actually a domain expert. Like for example, in our field, I'm the product owner and I'm also a technical person, so that allows me to be both. But that's not necessarily a luxury everybody has. And so the first question was how do you what is a good team size to do this? So our team is 3 people. We do this, and it saves us a lot of time. And it's only one marketing/strategy guy, myself as a product owner and technical person, and Jonas, our technical co-founder. So it's only us 3. And so this technique works from anywhere from 2 people up to, it can really scale. It can really, really scale because, when you have a capability, you can have entirely different teams working on different capabilities. I'm actually pointing at there we go, that one. So what I was saying before, you have capabilities and feature sets. You can actually have a whole team working on one feature set and another team working on another feature set, and this thing can scale. So it's from 2 to hundreds. So full stack devs rules. Yes, absolutely they do. I mean, Also, using one technology across all these different parts, something like Meteor, only makes this process easier. You know, if you have to have a feature being delivered by one person doing your back end and one person doing your front end, it's possible, it'll work. You've got the domain test to protect you, but you know, it's a pain.
Yeah. So, can an echo? Fabio asks, I saw your comments about space and DDD. How could event sourcing help us deliver high quality features faster?
So I rubbed out the middle file, but the thing with space, or actually it's not necessarily space, it's the space is addressing a specific part, which is the CQRS. CQRS, command query reads, what it does is it separates your reads from your writes. And so typically when you're doing the persistence part, that's where you get what's called infrastructure leakage. That is, you're writing your domain, but then you're taking care of the persistence within your domain layer as well. And so your infrastructure has leaked into your domain. Typically, this happens in something like, you know, Meteor, where you finished processing a record and then you want a collection object and you want to save it. So, you know, sometimes it's just difficult to try and abstract that. You know, you want to try and keep that in the application layer. So you put it in the application layer, but it can still get difficult, especially if you have nested or relationships within data models. So then, you know, your application layer is still in there saving this object and saving that object, and then maybe going into that object and saving some other thing inside it. So CQRS gets rid of a lot of that hassle because it's no longer based on a snapshot of data. It is just based on the events. So it converts all your domain events into it models them as real events. You know, like for example, customer purchases a car, or I transfer $10 from Josh to me, not the other way, because I want $10 from Josh. So, you know, if I transfer from $10 or maybe $100 from Josh to me, then that's an event. And that event is what gets stored. And over time, you get all these events. And so in order to know where you currently are, all you got to do is start from zero and run through all the events and then go, all right, that's where I'm at. That's the current state. So within CQRS, there's also another mechanism to take snapshots along the way so that you can fast forward and then replay events from then on. So with your write model, you no longer have to worry about you know, any like transactions or anything like that. You just write fast and furious, and then and it's always correct because your write is always writing the current event. But then for your reads, you end up with what's called like eventually correct, eventually accurate. I can't remember the exact terminology. But anyway, in doing so, it's actually more complicated as a domain model. But you know, as your application grows, it means you no longer have to worry about refactoring your data model constantly. What you've got is a history of all the events that happened. And let's say you even want to retrospectively go back and change the way that the transfer algorithm worked. You can actually go back in time on your data and replay all those events. So your maintainability of your system actually increases by using something like CQRS. So initially it will be hard, but I'm talking about like once you get to complex, like once your application is, you know, 6, maybe 2 years onward, something like that, a large team has been working on it. You know, having something like the separation between reads and writes is another level of separation of concerns, which is ultimately going to make your system more maintainable.
Nice.
CRUD versus CQRS, I think I covered that. Did that cover it?
Yep. All right. Well, thank you, Sam.
Sure.
It was a great talk.
Thank you. Cheers.
Yeah. All right. I put a link in there for the next talk, so everyone can click that and watch Jeremy. This video has been a Space Dojo production. You can click the Learn More button to find out more about us at spacedojo.com. Or you can click the subscribe button to get notified about new videos we put out each week. Thanks for watching.